Okay. Hi, welcome to my presentation. So this is my thesis topic. It's nothing but to evaluate the performance of a distributed tracing under the dynamic workload in a Kubernetes-based microservice using different sampling technique. So let's move on to the next slide. So these are the presentation outlines. So these are the topic I'm going to cover. So what motivated to me to take this topic? So in nowadays, all the backend architecture is changed to monolithic to the microservices. Suppose we have 100 microservices. If request coming from one request to one service to another service, if any problem that if any error that happen between two microservices, it's caused a lot of problem because in 50 like 100 microservices, I need to we need to find which service is breaking down, which service is error right now. So it's very hard to debug and hard to find the error. So that's why we are using distributed tracing. So nowadays we are using like most of the developers using open telemetry thing, which is open source. We can use that. It's a like common thing, it's a common package. Open telemetry is an open source. So that's why most of the developer using it right now. So inside that, we can analysis the CPU, memory, latency, cost as well in every traceable request. So in here, I'm using three like sampling strategies: problematic, head base, and the tail base thing. And so we can later discuss that in the upcoming slide. And the last one is there is no existing study to compare these all the sampling method under the dynamic workload in a Kubernetes-based environment. So these are the reason why I'm to keep taking this topic as my thesis. So let's move on to the next slide. So these are the research question and my other objective. Two objectives I have. The one is like first one is performance. Compare the performance of a lot of different sampling in a Kubernetes-based microservices like CPU usage, memory, latency, and the cost. And the second objective is how the system behave in the dynamic workload, in a steady workload, for spike workload, as well as a RAM workload, how the performance over in the different sampling. So let's move on to system architecture. So this is my system architecture. So the first one, like I have front end and five microservices. Front end I'm using React, five microservices I'm using Python Flask, and all the like including front end and back end I deployed in Amazon ECR. I'm taking the image from there, and all the ports I'm running Amazon EKS cluster, altogether 10 ports, five microservices, one React front end, and four observatory thing. These are the observatory things, 7, 8, 9, 10 ports. Or when we are looking here, all the requests from the microservices is called for the open telemetry collector. So inside we can see the all the trays that go from microservices to open telemetry collector. So this is how it find that if any error that happened between two microservices, all the details can getting in open telemetry collector on port 7. Inside the port 7, there is a two section for the traces. All the traces all go for the Jaeger. The Jaeger is nothing but we can store the like trace over here. We can visualizing trace one by one over there. We can discuss in the I can show in the demo session. And the metric side, all the metrics under CPU, memory, latency, all the metrics we can take by the like parameters, and the parameters later send to the Grafana. Inside the Grafana, we can visualizing the metrics over here. So this is my entire architecture. And one more thing, K6, I'm using the test, like load testing, I'm using K6 generator. Let's move my next slide. So these are the equations. So these are the basic equations. So CPU utilization, total CPU utilization is a summation of the CPU per like one or like need to be some of the total CPU utilization, all the 10 ports. This is written over here, total 10 ports. So in the peak time, I'm calculating the CPU memory at the peak time. Also in the latency, this is 5 microservices. I'm taking the mean of that. This is a and another formula is proxy cost index. It's just a proxy cost index, not related to any AWS billing criteria, AWS cost. I'm using just for the proxy cost index. Like that's why I'm naming as a proxy cost index. So these are the important ports. This is a four sampling configuration. First one is zero cost tracing. That means the totally this case is disabled here, not tracing the happen between the microservices. So problematic is only 10%. That means 100 requests are coming into my system, only 10 is trackable. The 90% is just discarded. The head-based sampling is how like 100% of trace like request is traceable, and the last one is trail based, where all the requests are waiting for 5 seconds inside the open telemetry collector, and if any error happen between the requests, the request like error request is traceable. 100% of error request is traceable, and that if the request is success, only 10% is traceable. So this is a open tail based sampling configuration. And the next thing is the workload scenario. These are the three workload scenarios. Like first one is steady 15 versus user for 3 minutes, spike starting with the 5 user, reached 30, and again down to 5 for 3 minutes and 10 seconds. And the ROM case is starting from 0 version user up to 13 version, and again decrease to 0 in 7 minutes. So these are the workload scenario. So this is experiment number one in steady, spike, and the RAM cases. When compare every three graph, we can claim that we can like see the tail-based how using more maximum like overhead to our system, like more than 50 percentage when compared to not tracing and problematic tracing. Like we can in the steady there is 31, the spike 52, the RAM is 54. You can so there's the tailbase have the most overhead than any other because it's have 5 second window size as well as 10 percentage like 10 percentage success tracing, and the 100 percentage error request is traceable. So these are the anomalies I'm facing. So first one, I'm sure that inside this CPU utilization case, open tracing, no sampling is greater than problematic sampling. When we when we theoretically when speaking, only 10 percentage is trackable. So there is no 0 percentage is trackable in no tracing. So there is a little overhead when we are speaking. The no tracing is need to be lesser than problematic sampling, but somehow it happened opposite. So these are the anomalies, and the limitation is first one is 5 seconds, and make it as a fixed throughout my configuration. That's because I need to be early sampling is differ now. The rest of things I need to be constant. So that's why. And the CPU, like CPU throttling is not calculated. I'm taking the standard deviation, not me. I'm taking mean of the like different experiment, not a standard deviation. And these are the conclusion. The overhead ordering is no sampling is lesser than problematic, which is lesser than head sampling, and which is less than the tail-based sampling, because tail-based is the highest overhead, and the problematic sampling is most resource conserving across all scenarios. And I fulfilled all the two objective. Future works is kind of this. I need to verify the varying the window size, enabling the Kubernetes auto scaling, and extend to the Go language or Java language. And this is my GitHub repository. Thank you. And let's move to my demo. And this is my website, front-end website. So this is why I took the e-store thing. And let's add to cart one mobile phone and place order. So this is a request right now, which is 200 right now. So it's that every request, all the microservices, all the 5 microservices in array. And we can start the case 6 scenario. This is a cases scenario. I'm starting steady for the 50 virtual user for the duration of 3 minutes. Right now, I am on tail-based sampling. Tail-based sampling right now. So this is the power script. I'm just copy paste that thing, and I'm just enter press enter. And right now the case is starting running right now. Starting with 15 virtual user. And let's go for the Grafana. And Grafana is right now is 1.59. Let's wait some time because we are giving load in here. It's raising, or it will raise soon. Uh, it will raise soon. Yeah, it's raising right now. So all service is kind of raising, or the yes, this is raising. Overall CPU is raising, as well as memory usage is also raising right now. Yeah, it's raising, and it's using 70.3, and it's almost altogether is 3 minutes. It's reaching 23 percentage, and the memory usage is like this memory usage. And this is another way of happening. This is the tracing that happen right now. Is 20 requests per second is happen right now. And this is a trace, the spam is created like this, trace is used, and we can go for the Jagger, the all service right now on route service for the last request. These are the like the last request, the post for the place order thing, 14 spam created, 5 services, and every touching auth, order, payment, notification, and users. We can compose in here, like here, like sorry. And these are the, so this is the current time. Look at the current right now. This is a live demo. And so that all about. And one more thing is how I getting the latency. So I'm getting the latency from here. So auth order, every latency I'm getting from here. So let's move to, I'm just stopping right now. I need to run one more configuration and changing this to tail to head sampling, how I'm changing or to this. And now I'm changing apply changes. This is also the power script right now. And it's changed to tail mode into the head, like tail mode changed, sorry, change the tail mode into the head mode, or the reconfiguring the thing Kubernetes thing, or the thing is terminated and the new port is restarting right now. I'm checking the port status. This is a comment, and the old the port is terminated and the new port is starting right now. And just wait for some just wait for some time. Yeah, this is error. Okay, let's start one more time. Yeah, all the port are starting right now. Like, look at this age, it's 42 seconds ago. The new port is starting, or the port is terminated with the new configuration, head sampling. And we can go for the, okay, this time I'm running spike thing. I'm go for this. Yeah, starting with this one virtual user, gone up to 30, and look at our configuration right now. Right now, the value is reached to 0 because there is no load I getting in my system. Now it will rise soon. We can please eye on here. It will rise soon. Yeah. Starting with the 5 virtual user, no, starting with 0 virtual user, it's increasing, and finally it's reached to 30. And now it's still 13, 14. Also the, yeah, also the, we can show the trace in here. So these are the live demo of the trace. One can show the, so we just bypass the front end. We can directly give in the pressure to this endpoint, place order endpoint. So now it's start 330 out of 30. All the full strength virtual user I'm giving right now. So now all the thing is rising now. Look at this, the graph is rising, and we can go for here as well as here. Yeah, in here I'm looking this. I'm getting the overhead, like all the latency in here, P50, P95, and P99 latency I'm getting here. So this is where I'm getting the latency or the spam I'm collecting here. Yeah, look at here. Yeah, it's reading 45 right now, and this is a GB right this. So, and wait for some time, it will reduce soon because it is reduced to like 35, 32, something like that. And it will reduce soon because the pressure we are like uh, testing we are reduced virtual users nothing but the users, like real life users. Instead of real life users we create virtual users. Right now it's 10 user using right now, and it is reduced it will you already see the 45 we are reached, and now it's reduced to uh, it will reduce, or the thing is reducing right now. Yeah, here it is. Yeah, now it's 35. Yeah, all the thing is reducing right now. So this is my entire project, and all the, and this is my cluster. All the like all the pods are running is this like EKS cluster. So now it's reduced to 21 percentage because it's all the thing is successful. Yeah, so this is my entire project right now. So now you got an idea about how that sampling is, like uh, like get an idea about sampling and overhead, how it affect the performance altogether. So thank you so much.